Hello, everyone. Um, this is my project on how to obtain biodegradable polymers from renewable resources. Now, first we must understand why do we need these? Why do we need biodegradable polymers? Now, we know that using non-biodegradable polymers such as polyethylene and stuff takes a heavy toll on our environment, right? There is a lot of environmental damage, and they end up in the landfills, and we don't know what to do with the waste. We cannot burn it. So it's really preferable for us to go for biodegradable alternatives because how we define biodegradable polymers is they degrade and catabolize eventually to carbon dioxide and water by naturally occurring microorganisms, and they do not degenerate into substances toxic for the environment. So they're really good for the environment. Now, why do we need to obtain them from renewable resources? You see, we are running out of fossil fuels, and within the next 50 years, the prices will steeply increase, and they will be really costly. And by the end of by the end of the century, we might have even run out of fossil fuels. So, plastics are used, polymers are used in our day to day life, and if their cost goes up, we cannot really handle that, can we? For instance, imagine the cost of a packaging bag to be 2000 rupees. It's just absurd. So, they must be obtained from renewable resources and not from fossil fuels. So we should go for biodegradable polymers obtained from renewable resources. Now, which is the best option for us to go to? The answer is lactides, because they are derived from 100% renewable resources, um, by fermentation of corn or sugar beets, and lactides can be used to produce polylactides after polymerization. And yes, polylactides are biodegradable. That is, you can recycle them, you can make compost out of them. And this diagram tells us about the life cycle. You see, polylactides, you, let's say you grow corn, and then you get lactic acid from sugar fermentation, and from that we get polylactic acid resins, and then we manufacture products. The product is then used, and the product is then disposed. The PLA degrades into CO2 and water, and that kind of helps us grow corn again. It's a nice life cycle, but it's not so for non renewable plastics. We end up with lots of waste. And now, how to synthesize polylactides or PLAs? Well, I read my share about this, and I realized that the most effective way to do synthesize PLAs is through ring opening polymerization, which we will call ROPs. It's a really huge term. So now, the most studied method is using metal based catalysts. So after experiments, using these metal based catalysts showed very high rates of activity and excellent molecular weight control in lactide polymerization. So, using metal based catalysts can really help us. Now, we come to products from PLA. We can derive many products from PLA, as you can see. We can derive bottles, we can create disposable glasses. When we do have paper cups, we can create packaging materials. Yes, those are socks. We can also create socks, mats, anything we want really. Now, PLAs can be used to produce renewable bottles with short shelf life. Special emphasis on that. Containers, etc. And they can replace the non-biodegradable plastics that are there today. Now, this is important. PLAs have been categorized as generally recognized as safe by scientists and researchers when in contact with food. So, it's generally safe. It may produce a little bit of lactic acid, but it's not in the concentration that is harmful for the human body. And of course, PLAs can be used as packaging materials and for making containers. So, how do we conclude with this? PLAs can save us from producing loads of non biodegradable waste, which end up filling our landfills, and we don't know what to do with the waste. It's a huge issue. Waste management is a huge issue right now. And they also reduce our dependency on fossil fuels. Right. And I think PLAs are the future. They have already been used a little bit in certain industries, but they have not come into mainstream use. And well, PLAs are the future. You see, we will be using PLAs for everything in the future. That's all I have to say. Thank you.